Hello students, today we'll be talking about rest and motion from the kinematics portion. Today we'll be talking about average speed and instantaneous speed. So let us start off with average speed. The concept of average speed is very straightforward. The thing is that if you travel a distance, suppose s, in time from, you started in time t1 and you traveled up till time t2. So the time interval that you are considering over here is basically t2 minus t1. Let me write it down for you. So here distance will be s, and the time interval that you are considering will be from t1 to the time t2. So in this case, the average speed will be given by, so in this case, average speed, and average speed in general is denoted by V of AB. VAB will be equal to S upon T2 minus T1. So as you can see, very straightforward definition. Average speed is basically the distance traveled by the time taken for the travel. So this is a straightforward answer. So now we'll be going into the instantaneous speed. So instantaneous speed is also very straightforward. But before you go into instantaneous speed, let me suggest a scenario for you. So the scenario will be that if we travel a distance, suppose delta s, in time interval from t to t plus delta t. So the time interval that we are considering is t plus delta t minus t, which will be delta t. So delta t is the time interval that we are considering, and the distance that will be traveled in that time period is delta s. So if delta s is the distance, traveled in time interval t to t plus delta t. So in this case you can see that delta t will be the time interval. We are going from time, it's not a time interval, rather this will be just in time from t1, from t to t plus delta t. So this is the time interval that we are considering. So in this case, average speed. So what will be the average speed in this case? Average speed will be the distance by the time interval. So the distance will be, in this case, is delta s, and the time interval that we are considering is t plus delta t minus t, which will be delta t. So now for instantaneous speed, what we need to do? So instantaneous speed is basically the speed at that very point or that very instant. So for instantaneous speed, our delta t will tend to be a very small number. So it will ultimately tend to 0. Delta t will tend to 0. And as delta t will tend to 0, delta s will also tend to 0. So basically it means that for instantaneous speed, delta t tends to 0, and that will imply that delta s will also tend to 0. So this is basically the for instantaneous speed, the condition for the instantaneous speed. So the instantaneous speed, which will be denoted by v, will be equal to the limiting value of delta s upon delta t as delta t tends to 0, and this entire structure can be written down as ds by dt. Now you need to understand one thing, that here delta t also is tending to 0 and delta s is also tending to 0. So basically it is tending to a 0 by 0 format, but as you can see, this is a finite ratio and not 0 by 0 format. So this will be the instantaneous speed over here. So this is what we know in theory. Now I want to show you in a graphical way how we need to understand the average speed and the instantaneous speed. So let us begin. Let me rub it out for you. So what we'll try to do is that we'll try to plot the distance, that is the s, over time as a function of time. So let us take a graph for that very scenario. So basically here we are plotting s in the y-axis. This s is the the distance, and time in the x-axis. So suppose we have a function s which is a function of t of this very format. So as you can see, here we have plotted s against t. So now if we go, suppose at time t, we are at the point A. So this is the point A. And then at time suppose t plus delta t, we are at the point B. So as you can see, this chord AB will be basically, we can see that here the distance is delta t, and here since we are going from A to B, and the distance traveled will be basically delta x. So from S1, and this is S2. So as you can see, the slope of this chord AB, is equal to delta S by delta T. So as you can see, this is basically delta S by delta T is nothing but the average speed. So you are able to understand now that how we are finding out the average speed from the graph. Now for instantaneous speed, what will happen? For instantaneous speed, this delta t tends to 0. Now if delta t tends to 0, basically this chord AB will become the tangent at the point A. So let me write it down. As delta t will tend to 0, this chord AB becomes the tangent at the point A. Let me draw the tangent for you. So this is the tangent. So the statement that we need to write is that as delta t tends to 0, chord AB becomes the tangent at the point A. So this is the statement that we need to remember, that as delta t tends to 0, chord AB becomes the tangent at the point A, and the slope of this very tangent will give us the instantaneous speed at this point A, and this will give us that slope of the tangent will give us the instantaneous speed at time t, basically at time t. So this is the important thing that you need to remember. So let me rephrase it once more for you. We are drawing the curve for s for distance as a function of time. We have drawn it, and then the chord AB, the slope of this chord AB is giving us the average speed, and the slope of the tangent at the point A will give us the instantaneous speed at this very point. So this is all about average speed and instantaneous speed. Now one more thing that you need to remember is that basically if we know that the instantaneous speed is given by ds by dt. So that implies that ds is equal to v dt. So if s is the distance in time from t1 to t2. So if s is the distance traveled in time t1 to t2, in this case s will be equal to integration v dt, where t goes from t1 to t2. So this is basically, this structure is nothing but the area under the velocity curve when we plot velocity as a function of time. So suppose, let me rub it out. So suppose we plot the velocity as a function of time. Suppose this is the function, velocity function, and then this is at time t1 and this is at time t2. So this very area, this shaded area, gives us the distance traveled in between the time from t1 to t2. This is the area is equal to the distance. So this is another thing that you need to remember from an exam point of view. So today we have talked about average speed and instantaneous speed. In our next video, we'll be talking about average velocity and instantaneous velocity and its application. We'll be also learning about a position vector in that very video. Till then, all the best for your upcoming examinations. Thank you very much.